We're going to talk about some card problems. There are 52 cards in a deck. There are 4 different suits. There's the names, but there are 2 red and 2 black. And there are 13 of each card. They are numbered 2 through 10. And then there's an ace, jack, queen, king. Okay, so that's a total of 13 clubs, 13 spades, 13 hearts, and 13 diamonds. That will help if you're not real familiar with cards. The probability is simply the measure of how likely an event is to occur. And the sample set is the set of all possible outcomes. So if I was rolling a die, I could roll a 1, 2, 3, 4, 5, or 6, and you would list it as a sample set. For equally likely outcomes, like rolling a die, if you have a fair die, the theoretical probability of an event is, how do they write this? The ratio of the number of favorable outcomes to the number of total possible outcomes. So we would say the probability of an event is number of favorable outcomes, what we want to happen, over the total number of ways that it could happen. Okay? So you've done this for years, I'm sure, but a jar contains 32 red and 28 blue marbles. What's the probability you pick a red? That would be 32 out of a total of 60 marbles, which you could reduce by 4, I think, to 8/15. Okay. This one, a letter is selected in the word restoration, randomly selected. What's the probability of selecting a vowel? So it doesn't matter that they repeat. If we threw these all in a bin, there are 11 letters in that word, and 5 of them are vowels. 1, 2, 3, 4, 5. Okay? Number 3, I've included, you can always look these up on the internet this year because you have access, but a lot of times it'll talk about days in a month, so you might have to look up how many days. But it says the month of January is randomly selected. What's the chance of picking a prime number? Okay, we got to know what prime numbers are. You can look up a list of primes if you are really desperate, but a prime number is one whose factors are only divisible by the number in itself, and by definition it has to be a number 2 or greater. So 2 times 1, actually 2 is the only even prime number. Everything else is divisible by 2. 3 and 1 are the only factors here. 5, 7. Now when we get to 9, 9 is 3 times 3. 11 is not divisible by anything. 13, 14, 15, 16 are all divisible. 17 is not. 19 is not. 21 is. 23 is not. 24, 25, 26, 27, 28, 29, 30, and 31. There we go. So I circled the primes. So what is the probability of picking a prime number? It is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 prime numbers out of 31 days. All right. So when I actually did the problem the first time, I just sat there and listed them. 2 is prime, 3 is prime, 4 is prime, till I got to 31. But I put a calendar on here to help you guys. All right, number 4, 2 dice are rolled. What is the probability that the sum of the 2 dice on the next roll is at least 9? These are all the ways you can roll 2 dice. Okay, you could get a 1 and a 1, a 1 and a 2, or a 2 and a 1, or a 1 and a 3, or a 3 and a 1, and so on. All right, and you can, save that little chart somewhere. But honestly, I just looked and said, well, to get a 9, I only have up to a 6, so I could have had a 6 and a 3, or a 3 and a 6, or I could have had a 4 and a 5, or a 5 and a 4, and that's the only ways I can get 9, right? Nope, I'm missing something. What am I missing? 5, 4, 3 would need a 6. Why do I have more than that on my paper? Oh, at least a 9. I'm sorry. They could also total 10. So I could have a 6 and a 4, or a 4 and a 6, or 2 5s. I could get 11, which would be a 6 and a 5, or a 5 and a 6, or I could get a 12, which would be a 6 and a 6. Okay, so, sorry, my brain is. So anything that totals 9 or greater would be all of these choices down here. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 ways that could happen. Out of 6 times 6 or 36 ways it could roll. So we have 5/18 as the reduced fraction. Sorry about that. All right, number 5, what is the probability of drawing a heart or a club from a standard deck of cards? Some of you are going to answer that really quickly because a fourth of the deck is hearts and a fourth is clubs, so half of the deck, okay? But if not, you would have to say there's 13 hearts and 13 clubs, so you have a total of 26 winners out of 52 cards, which reduces to 1/2. All right, this is a tricky question. This has more to do with what we did earlier today. If there are 8 books lettered A through H on the shelf, if Scott randomly chooses 2 books, what is the probability that he chose books A and B? So out of 4, he's choosing 2. So we have to do a little bit of combination. Okay, there's 8 books. 8 books. 8 books. Okay, out of 8, he's choosing 2, which if you type that in your calculator gives you 28. So there's one of the ways out of the 28 ways he could choose 2 that would choose books A and B. I don't think I assigned any like that. All right. The complement of an event is simply the probability that the event does not occur. Since the sum of all probabilities is 1, the probability of an event not occurring is 1 minus the probability that it does occur. So you guys get this. If the chance that it will snow tomorrow is 7 out of 20, the chance it will not snow is 13 out of 20. All right. A month of the year is randomly selected. What is the probability that the month does not begin with the letter A? Well, if you look through this list, and I put it on here because it will help with the number of days for some other questions too, but we only have April and August that start with A, so that means there are 10 that do not start with A. So we'd have 10 out of 12 or 5, 6 for that probability. All right. If a spinner to the left is spun, find the probability that lands on a prime number. Oh, a number that is not prime. All right, it'd be easier to count the primes though. So we have prime, doesn't divide, 11, 13, the rest are not. So we have 1, 2, 3, 4, 5, 6 out of 16 that are prime, so that leaves 10 out of 16 that are not prime. Is that what I have? Yes. Okay, which reduces to 5/8. 2 dice are rolled. What is the probability of not getting doubles? Well, let's just think about the probability of getting doubles. We could get a 1 and a 1, a 2 and a 2, a 3 and a 3, 4 and a 4, 5 and a 5, or 6 and a 6. So out of the 36 ways that it could happen, 6 out of them would give us doubles. So 1 or 36 out of 36 minus the 6 ways we could get doubles would leave 30 out of 36 ways we cannot get doubles. So this is the probability of not getting doubles, and that reduces to 5, 6. All right. When you have independent events, you just multiply the probability of event A happening times the probability of event B happening. So a die is rolled 3 times. What's the probability of getting 1s each time? So it's just 1, 6 times 1, 6 times 1, 6. This happened to be 3 events. So you just multiply them. So this was 1 over 216. If a coin is tossed and then the day of the week is selected, those have nothing to do with each other. So getting tails would be 1 out of 2. Selecting a probability the letter of the week starts with a T, we'd have Tuesday or Thursday. So 2 out of 7 would work as winners. When we multiply those, we get 2 over 14 or 1/7 as the probability. So you just multiply when they are independent events. So independent means that one is not affecting the other. So this says a bag contains 8 red crayons, 14 purple, 6 yellow, and 4 green. So there's 22, 32 crayons total. A crayon is selected and replaced, which means two things have nothing to do with each other. So the chance that you pick a purple is 14 out of 32, and the chance that you put it back and then pick a yellow would be 6 out of 32. Now, you can do this on your calculator and do a math enter. I'll show you one just in case. But you could do 14 over 32 times, and then it was 6 over 32. Oh, don't really need all these parentheses. It's better to put extra parentheses. Sometimes you need them. And then you can either hit enter and then math enter, or at this point you could hit math enter and say I want a fraction. And you get 21 out of 256. All right, green and then red. I'm not going to bother to simplify these. I'll just set them up. But green would be 4 out of 32. We put it back, so there's still 32. When we go back to do red, there's 8. 2 purples. There are 14 purples. We put it back, and so there's still 14 more. And you could simplify that. Okay. Then it talks about dependent events. Dependent events mean basically you're not replacing that crayon. Okay? The two things depend on what happened the first time. The number of items is not the same. So we're supposed to do the same directions as above. So I put them up here again. But there's 32 crayons. So this time, when we pick a yellow one, there were 6 out of 32 to pick one. But when we go back, remember there's one less crayon now. But the red ones are all still there, so we have 8 out of 31. So if you multiply that and reduce it, it comes out to 3 out of 62. All right, purple and then a green. There were 14 purples. When we go back, there's still, all the greens are still there, so we'd have 4 greens, but now there's only 31 crayons because we left the purple one out because it says not replaced, okay? 2 reds, this is a little bit different. You would have 8 choices out of 32 the first time. When you go back to pick, there's only 31 crayons now, but there are also only 7 red left. So it's 8 over 32 times 7 over 31. And that came out to 7 over 124. All right. A card is drawn from a standard deck not replaced. So we're doing dependent events here. And another is drawn. What is the probability of choosing a heart? So the first time we go to pick, there are 13 out of 52 that are hearts. And then we left that one out. So there are now 51 cards to choose from. But when we go to choose a spade, all the spades are still there. So there's still 13 spades. Okay. This reduces to 13 out of 204. Jack had 4 Snickers bars and 8 Mars bars. He randomly chose a piece of candy, ate it, and then chose another. What is the probability that both were Snickers? So he had 4 out of 12, total of 12 candy bars to pick from the first time. And then he ate that one, so now there's only 11 to pick from. But if he wants another Snickers, there's also only 3 Snickers to choose from. Now here, 4 times 3 is equal to 12, so this would all divide out, and you get 1/11. All right, conditional probability means that you're concerned about a certain condition being met. So is the probability of an event, given events A and B, conditional probability is the probability of event B occurring, knowing that event A has already occurred. So the notation is this like single absolute value looking line, okay? And it's read as the probability of B given A. Probability of B given A. So Mitchell drew a card from a standard deck of playing cards. What is the probability that he drew a queen given that the card was red? So we know he has a red card. So there's 26 red cards. There are 2 red queens, one of diamonds, one of hearts. So the chances are 2 out of 26. Hey, there's fancy formulas for this, but if you just think through the number of choices, you will be fine, and we don't have to use ugly formulas. A number from 1 to 100 is randomly selected. What is the probability that it is a perfect square given that it is an odd number? Okay, there are 50 odd numbers from 1 to 100 because half the numbers are odd. Every other number is odd. Now we need to figure out how many perfect squares that are odd. So 1 times 1, 2 times 2 is even, 3 times 3, 4 times 4 is even, 5 times 5 is odd, 6 times 6, 7 times 7, 8 times 8, 9 times 9, 10 times 10. Okay, so in the first 100 numbers, there are 5 odd perfect squares. So 1 in 10 is the probability of picking that. Have to be careful as we calculate these. All right, number 3. This is a kind of question that I would use a Venn diagram for, okay? It says there are 62 people that take yoga class and 48 that take spin at this gym. 15 people who take yoga also take spin. So we have yoga and spin. So 15, it says here, take both. And if a total of 62 take yoga, so the leftovers would be 62 minus 15 or 47. Did I do that right? And take spin, there's a total of 48. So 48 minus 15 leaves 33 who do not take both. All right, if a person from these groups is chosen at random, find the probability that he or she takes yoga class if you know that they take spin class. So we are talking about this is our given population. We know they take spin. So that was 48 people. But what's the chance out of those 48 that they also take yoga? Well, that would be these 15 people that overlap. Okay, those both reduce by 3, so you get 5/16. Tricky, tricky. Got to think these through. All right, there are 30 students in Miss Smith's math class. 13 are athletes and 9 are in band. Of these athletes, 3 are also in band. So we have athletes, band. There were 9 in band altogether, so 9 minus 3 leaves 6 who are only in band. There are 13 who are athletes, 3 are in both, so 13 minus 3 leaves 10 who are only athletes. We had 6 and 3 is 9 and 10 is 19 represented. So there's actually 11 other students. 30 minus 10 minus 3 minus 6 leaves 11 other students who were not any of those. Find the probability that this student, chosen at random, is in band if we know they are not an athlete. Okay, so not an athlete would include these and these guys. So there are 17 choices for not an athlete. What is the probability that they're in band would be those 6 students who are in band. Wow, those take time and thought. All right, when we have a table like this, which is what you will see a lot of in Delta Math and on the quizzes and tests, are table questions like this. The table shows the results of a poll of 50 randomly selected students who are asked whether they prefer to watch hockey or football. Okay, so there was a total of 28 boys if we add down, 22 girls, which totals 50 students. If we add prefer football, we'd have 24. Going this way, we get 26. That also totals 50. Okay, just helping us for some of these questions. Prefer football given that they are a girl. That means girl is the denominator. Okay, we can only pick the girls, and there are a total of 22 girls. How many of them prefer football was 6. So 6 out of 22, which reduces, I'm just not going to worry about it. All right, the probability that you pick a boy given they like hockey, okay, given hockey means the denominator is all the hockey. So that's 26. How many of those 26 were boys was 10, which reduces, and you can reduce, okay. So the table below shows the fate of first, second, and third class passengers of the Titanic. Very depressing here. What is the probability that a third class person was a survivor? So we need to total, oh, out of everybody it says. Okay, so we'd have to do a bunch of math here. Let me write these down for you real fast so we don't spend time. I used my calculator to add all these up. And then I added down this way. And I checked that they added both ways to a total of 1,300 people. All right. So the chance that we had a third class person who survived, third class. So 172 are surviving a third class survivor. Okay, there were a total of 709. Okay, this is the problem. I'm not reading this to you right. Third class survivor means they were third class given that they survived. So third class given that they survived. Third class is 172. Okay, a third class survivor. 172 out of a total of 488. Okay, third class survivor. So all the survivors, the ones that are third class. All right, sorry, I didn't explain that well at all. A first class person given that they died. So the total number of people who died, okay, goes on the bottom. And then first class was 120. Yeah, you can reduce some of these. I'm not going to mess with it. Survived given they were second class. So the denominator is all the second class. And survived was 117. Okay, so the second part is the denominator. Did I cut off choice D? I guess I did. I don't know if you have choice D. Choice D says first or third, given that they survived. If you have that on your sheet, the given that they survived, a total of 488 people survived. If it doesn't matter if they were first or third class, you would add those two as the number of people that you're okay with calling winners, okay? So we would add and get 371 out of 488. I don't know why that's not on my slide. Maybe you have it, maybe you don't. All right, that's it. Sorry this video is so long. Good luck.